all being figured out, my name is Jonah Brown. I'm 17. I've been homeschooled for pretty much all my life, just excepting 1 year, but yeah, pretty much all my life. I'll be speaking about the math in nature in a little while, and that's directly pertaining to the Fibonacci sequence, and I will explain all that in a moment. So, enjoy yourselves. Commercial break. Lay's potato chips are great. I could send it to myself.
What's that? Is this? It's in this computer. So.
I didn't set this up there. And my guess is that computer is with that.
You have to open the screen on the projector. Is that with the screen open?
Yeah. Sounds like it's turning on.
Smart classrooms. Yeah, and everything's integrated. Yeah. Thank goodness, because I don't. We used to use them. I don't remember how to do them.
He's been using them for so long.
Thank you. I appreciate it.
Oh, you have the web internet?
Yep. Okay.
Is online.
All right.
It should be.
Math appears in nature in numerous forms, but the one I'll be talking about today is specifically the Fibonacci sequence. The Fibonacci sequence was first introduced by Leonardo da Pisa in 1202 in his book Liber Abaci. The Fibonacci sequence is a series of numbers in which to get the next number in the series, you have to add the previous two. So starting with 0 and 1, starting with 0 and 1, you add 0 and 1 together to get 1, so the next number in the series will be 1. Following this pattern, you add the next two, which is 1 plus 1, you'll get 2, so the next number in the series will be 2. Going on, 2 plus 1 is 3, so the next number will be 3. You can follow this series through infinite amounts. So, if you make squares, and use these squares with equal sides that are each length according to the number they represent in the series. So, starting with 1, you have a square with equal length sides that are equal to 1. The next one will be 1 again. And if you go counterclockwise, placing them around each other, you'll get a little figure. So you have 2, then 3, then 5. If you place 90-degree arches going counterclockwise within each square, you'll get this figure. This is what is called the Fibonacci Spiral. This is what's going to appear in nature many times. The first and most obvious example is in a seashell. If you notice, it shows the same pattern we have here that spirals around in the seashell. Another example is in the unfurling of a rose petal. If you see how it follows that pattern, it is almost exactly symmetrical to the Fibonacci spiral. Another example is in various forms of succulents. It spirals in the same exact way, almost exactly symmetrical. The next would be a sunflower. This one's a little bit more difficult to tell, but if you can see the lines in the flower, the curve that they're going on is in the curve of a Fibonacci spiral. The other one is pine cone. In the same way, it curves exactly that amount. The next one would be in a fern that has not yet, unfurled. So that's the same thing. It's doing the exact spiral that the Fibonacci curve represents. Another one would be spiral galaxies, such as our own Milky Way. It follows almost the exact same pattern that Fibonacci spiral represents. So from the greatest of things, like galaxies, and like such huge things like galaxies and even hurricanes also follow this pattern. From the smallest of things, like plants, and even how a baby sits in a mother's womb, the Fibonacci spiral is represented. All you have to do is look closely and think about it. And such pattern, such symmetry in nature, it almost proves that life is not random and chaotic as some people might think it is, but instead it's a creation, someone's divine work. Thank you.